Good evening, students. This is the lecture number 8. The topic is linear magnification produced by the lens. A very simple topic. What is the magnification? As we have discussed in case of a spherical mirror, okay, linear magnification of a lens is defined as the ratio of the height of the image found by the lens to the height of the object. Okay. So mathematically, linear magnification equals to height of image, that is I, and height of object, that is O. M equals to I upon O. Okay. In case of convex mirror, when image is real, so your linear magnification M equals to minus I upon O. Okay. So M equals to V upon minus U. When image is real, it is inverted and forms on the other side of the lens. Okay. And when image is virtual, so M equals to I upon O equals to V upon U. Okay. Okay. When image is virtual, it is erect and forms on the same side of the object. Okay. Thus it can be said that convex lens gives positive linear magnification for virtual image and negative linear magnification for the real image. Okay. And for convex lens also forms a virtual image, so linear magnification of concave lens is equals to M equals to I upon O and is equals to V upon U. Concave lens always gives positive linear magnification. Other formula for linear magnification can be M equals to V upon U equals to F minus V upon F equals to F upon F plus U. Okay. Okay students, our next topic is the power of lens. What is the power of lens? The ability of a lens to converge or diverge the rays of light incident on it is called the power of lens. This is the theoretical definition of the lens, but mathematically mathematically it is defined as the tangent of the angle by which it converges or diverges a beam of light falling at unit distance from the optical center. Okay. Angle by which it converges or diverges a beam of light. You can see in the figure for a convex lens, this will be your incident ray parallel to the principal axis after refraction passing through the principal focus. Okay. So it is a converging lens, so this ray converge at this particular point making an angle delta. Okay, at a unit distance from the optical center. Okay. So according to the figure, tan delta equals to H upon F. Okay. And if I take H equals to 1, then tan delta equals to 1 upon F. For small values, we can consider value of delta as tan delta equals to delta. So delta becomes 1 upon F. Okay. So the power of lens becomes P equals to 1 upon F, where F is your focal length, which is in meter. Okay. You can also say that the power of lens is a reciprocal of a focal length. Okay. SI unit is what? SI unit is diopter. It is a reciprocal of focal length. Okay. If focal length is 1 meter, then power is 1 m inverse, also called 1 d. D for diopter. Okay. By Lensmaker's formula, we have 1 upon f equals to mu minus 1 into 1 upon r1 minus 1 upon r2. P is 1 upon f. So this formula becomes P equals to mu minus 1 upon r1 minus 1 upon r2. R1 and r2 to be measured in meter, which are the radius of curvature of both the spherical surfaces of a convex lens, or in case of concave lens. Okay, for convex lens p is always positive, and for concave lens p the power is negative. Okay, so this is the power of lens. Okay students, now come to the next topic, which is the combination of thin lenses in contact. Okay, here we have considered two lenses L1 and L2 of focal length of f1 and f2 placed in contact with each other. An object is placed at a point O beyond the focus of the first lens L1. The first lens produces an image, that is I dash. Okay, that is the virtual image, which serves as a virtual object for the second lens second lens L2, and producing the final image at I. Okay, you can see in the figure L1 L2, the focal lengths are f1 and f2 respectively. This will be your point object. The ray which is passing through the lens which is coming from this point object after passing through lens L1, making the image I dash, that is the virtual image, or produces a virtual image I dash. This virtual image behaves as an object for this particular lens, that is L2. Okay, this particular lens, that is L2, which serves as a virtual object, okay, for the second lens, and producing the final image at I. Okay, so this u is your distance on an object from the surface of contact, and this is the distance of an image from the surface of contact, and I dash is also the distance from this surface of contact, that is v dash. Okay, since the lenses are thin, we assume the optical center P of the lenses to be coincident. Okay, we can consider optical center to be coincident. Okay, okay, recently we have discussed the power of lens, that is the reciprocal of focal length, p equals to 1 upon f. For thicker, if the surface is thick, okay, then convergent action is more, and if it is thin, then diverging action is more. Okay, unit is m inverse or diopter. Okay, in case of L1, object is O, so the distance of an object u equals to u, and the distance of an image v equals to v dash, and the focal length of lens L1 will be f1, so f equals to f1. So by the lens formula, 1 upon f equals to 1 upon v minus 1 upon u, it becomes 1 upon f1 equals to 1 upon v dash minus 1 upon u. This will be your equation number 1. Okay, and for the second lens, object is I dash. Okay, object is I dash, and image is I. Okay, so u equals to v dash and v becomes v. Okay, and let the focal length of lens L2 will be f2, so f equals to f2. So by the lens formula, we have 1 upon f2 equals to 1 upon v minus 1 upon v dash. This is your equation number 2. Now adding equation 1 and 2, we get 1 upon f1 plus 1 upon f2 equals to 1 upon v dash minus 1 upon u plus 1 upon v minus 1 upon v dash. This v dash, 1 upon v dash and 1 upon v dash will be cancel out each other. So 1 upon f1 plus 1 upon f2 equals to 1 upon v minus 1 upon u. This will be your equation number 3. By the thin lens formula, 1 upon f equals to 1 upon v minus 1 upon u. This is your equation number 4. Okay, so by comparing these two equations, we have 1 upon f equals to 1 upon f1 plus 1 upon f2. Okay, or if we have number of lenses, n number of lenses. So 1 upon f equals to 1 upon f1 plus 1 upon f2 plus 1 upon f3 plus up to dash dash 1 upon fn. Okay. As power equals to reciprocal of focal length, then p equals to p1 plus p2 plus p3 plus up to dash dash plus pn. Okay. If there is a separation between lens, if there is no separation, then formula becomes this. And if we have a separation between the lens, if we have separation between the lenses, then formula becomes 1 upon f equals to 1 upon f1 plus 1 upon f2 minus d by f1 f2. In terms of power, p equals to p1 plus p2 minus d into p1 into p2. Okay, the most important formula, it can be help those students which are preparing for NEET and JEE. Okay, the question may be asked from this particular topic, so you can use this formula. Okay. Okay students, this will be the end of this refraction through the lenses. Okay, so we have discussed already about the mirror, plane mirror, spherical mirror, and also about the lens. Okay, our next topic is refraction through the prism. Okay, which which we will continue in the next class. Okay, so um, keep your preparation on and solve the questions which I have given in the notes. Okay, and prepare your notes through the images of that notes which I have given to you. Okay, and try to solve the numericals related to the important formulas. Okay, and if you are facing any problem, you can ask in the WhatsApp group as well as in the comment box also. Okay, or you can message me personally on my WhatsApp number. Okay, thank you so much.